So this is a brief overview. We are going to keep this quite short, just a handful of slides and some demonstration of the products themselves for State Notifier and for Wake-On-WAN. So we won't go into great detail on the Wake-On-WAN side because I think quite a few people are familiar with that, but we will emphasize the benefits of how this is now integrating into State Notifier and also some of the new capabilities that people may not be aware of within there. So what are the solutions? So first of all, State Notifier. This is real-time and historical views of the state of your device and your users within your environment. So information about exactly what it is at the current time and what it was at any point in time that we've been collecting that information. Wake-On-WAN involves accurate, controlled and distributed Wake-On-LAN. So the ability to remotely wake up systems no matter where those devices are, without any of the inherent problems that people are familiar with Wake-On-LAN, the inability for that information to cross over the router boundaries. So what does this deliver? Well, first of all, with the information that we're collecting, we give much greater visibility about your environment. So this is the state information. Information about the state of your devices and users allow you to more accurately plan for deployments, to understand the utilization of the devices so that you can work out when your devices are available, whether that's simply before making sure that your assets are actually being used or for the most appropriate times to be performing updates. Also, because we're looking at the user states for the environments, we're also collecting an audit trail of access of devices. Who's been logging into what device and when they've logged out, and that information will be available to you from a security perspective, but also from a support perspective, so you can find the systems that people are actually on, rather than just the out-of-date information you may have within LANDesk. If as an organization you have green initiatives, or simply you're looking towards reducing power, while LANDesk has power management policies, it doesn't particularly give you much visibility about how devices are being used at the moment, and especially if you are applying policies, if those policies are truly taking effect. So with this State Notifier and the information there, we're going to be able to very quickly show you if your power policies are having the effect that you want. We're also, because we're monitoring these devices and the users, we have more accurate device monitoring. LANDesk has the ability to monitor a device, but through a simple ping. Is it available on the network at the IP address we last saw it? Now, if there's firewalls involved, we can't really get hold of those, and it's a simple state: is it on the network or not? So with State Notifier, we're able to monitor multiple states on those devices without the reliance on ping, and we'll see how that happens later on. And that information will be provided to you via pop-ups through the console, and also the ability for doing this through email alerting, whether that be to individuals, groups, even the service desk as well. And the ability to be notified about change in states, especially if we're looking this at a user perspective, is imagine your service desk being much more responsive than they are today. If we take a call from a user via email, that user may not be available when we're actually picking up that call and responding to them. And especially for distributed organizations, how do you know where that user is actually available, or as soon as they return to the desk? So being able to tell when a user's particular system comes online, or if they've gone away from the desk when the users come back again, allows that support operator to more rapidly respond and provide support to that user as well. And combining that information with the abilities for Wake-On-LAN, or Wake-On-WAN as we're terming it, the ability to do out-of-hours maintenance. So if today you're maintaining those systems through software updates, patches, you're doing that during the working day, you're impacting the business, you're impacting the daily operation, and the cost of that user's time and also the cost of the impact of the business can build up. The ability to wake up devices, perform maintenance to those devices, and optionally shut them down afterwards is something that has been a standard part of LANDesk for many years, but the restrictions, the limitations on the Wake-On-LAN technology have made that quite difficult to implement. So with Wake-On-WAN, we've the ability to not just wake devices, but to sequence pretty much any type of software distribution there without the limitation of just targeted multicasting which you have today, and really have much greater control over the shutdown or the power save of those devices after that job as well. So a high-level summary of the types of benefits you could expect to have by implementing this as a combined solution. So why do we need it? Well, part of the reason is that LANDesk, powerful though it is a snapshot-based data system. So while it does have some real-time capabilities, it's not implemented in this way. We don't see real-time updates within the database, within our view, for the systems themselves. And as reference, LANDesk Wake-On-WAN doesn't cross over routers, except when we're using targeted multicasting. And even then, targeted multicasting does have limitations in its ability to select a representative. And if you're simply trying to wake up one or a group of machines, you can't do that unless you're actually doing a software distribution task, so no ad hoc wake-up capabilities as well. LANDesk also assumes that you want the machine to shut down at the end of that task, which may not always be the case. And since LANDesk doesn't actually know if the system was online at the beginning, it could be accidentally shutting down machines as well. So a fairly common scenario that I've seen reported to me in the past is unexpected shutdowns of systems because somebody's left the Wake-On-LAN options selected on a task. And the only other option you've got available within LANDesk is vPro, and powerful though that is, it does have limited penetration into enterprises, into other organizations. So either it's limited in its support, it's not being configured, or you have a hybrid environment. So partial support means you've got a large proportion of your environment that won't be able to be managed, woken up and controlled shut down. So that's where Wake-On-WAN really plays. So let's take a look. So a standard LANDesk core server, so we're just running a Service Pack 3 LANDesk 9 system here. So this supports as well 8.8 and various different service packs in between. And what we're seeing are two main areas here. There is a MarXtar section, so that there is a server component that we install on the LANDesk core server. That will give us the Wake-On-WAN capabilities and also the ability to receive state information from clients. And there's a console plugin. We don't have to give that to everybody, we can just give it to the people that need the specific capabilities. And that gives us a MarXtar section within our toolbar and a MarXtar console. And within here we're able to see all of the devices that are being managed and receiving information for State Notifier. So in this case, I've just got 4 virtual machines running. We can see for each one of these their particular device state, online, the user state, so we have a couple logged in, a couple logged off, and what's happening with the monitor state, so we can see the screensavers are active, and the user state as far as whether they're actually in use, the keyboard and the mouse activity, and the current user information. So some of this we might expect to see within the LANDesk database, others we wouldn't. But we are putting this information directly into the LANDesk database as well. So in the same systems, we can see the current user, the logon state, the machine state, and the idle state for those devices. The fact that we're putting that into the LANDesk database means it's available for us for queries and for standard support operators that may be using the console but without the plugin. So let's see something that's changing. So we've got an XP client here. That's online, but it's logged off. So let's switch over to that device and show what's happening with the state updates. So login as the user. And as that changes, within a few seconds, XP client is now identified as logged on. It's now in use, so the idle state has changed, and we can see the currently logged on user, in this case Dave Miller, the user that I just logged in as. So that's virtually an immediate update that we've received. So very clear information about that. So if we're looking to support that user, we can see that as well in our LANDesk database. XP client, Dave Miller, logged on, in use. So we can know we could probably call that user now and provide support to them because we know they're active on that device. What happens if that user goes away from the system? So the screensaver could kick in, or as in this case, I'm going to lock that workstation. So similarly, XP client is now showing that the user has locked that workstation. Also within the MarXtar console, we're seeing that locked. So from a support perspective, we realize that that user probably isn't present. So maybe trying to get hold of that user isn't an ideal, but maybe there's something we could be doing to support that user because we know that user is away. But it's fairly recent in that the idle state of that device is still in use. and we can configure how long it is before we recognize that goes from in use to idle. So that's immediate state change information around the state of the device, the state of the user. But for each one of these devices, we have a history trial of what's been happening, when it's come online, when the user's changed, what that user changed to. So we can see that for individual systems, we can see it across all of the systems or groups of devices, and we have a range of dashboard views, so at any time we can see the current state of our environment. So if we're thinking of performing an update to the environment, how many of our devices are currently available? We'll be able to feed to our line manager, to the department manager, our expected success rate. If users are involved, how many of them are currently active on those devices? How many of them are actually using the systems? And we can see that from a current state. We can see that against any particular date and time as well. So if we are planning maybe to work out if we need to do power management, well, what was the state of play on Sunday evening, Sunday morning? Were devices online, and if so, were they actually being used at this particular time? So real knowledge about not just what we have, but how it was being used as well. And all of that information available to us to be able to compare against different dates and times, the behavior of devices across the week, so we can see the peaks and troughs of availability of devices and user activities as well, and understanding the utilization of the devices, the most actively used devices, the most inactive devices. We may have very expensive assets that simply aren't being used. They're never online, or if they are, they're just not being used by the people that they're assigned to. So useful to analyze that environment. Now from the user perspective as well, and this is one area where things change a bit against LANDesk. LANDesk is collecting information about the logging user, although those of you that have 64-bit Windows 7 will know there's a bit of an issue on there, in that it's not necessarily collecting the information correctly. But if in a standard LANDesk environment Dave logs off on this client, then LANDesk would still list that username against that machine. So from a support perspective, that's a bit difficult, in that we don't actually know which machine that user is currently on. Instead, what we're doing with State Notifier is we're actually paying attention to that. So if we log that user off, we're not leaving Dave Miller against that inventory record. That user will actually be wiped off from that machine. We will actually still store the last user for that device within the inventory record, but if we're searching to support that user, we will see by a search through LANDesk the machine they're actually currently on, but also within the State Notifier console we can see the currently logged on users and which systems they're currently on as well. So real-time visibility of user sessions and the devices that those user sessions are running on as well. So very useful for monitoring and also for support perspectives as well. How is that helping us with standard LANDesk activities other than user support? Well, because we're actually putting this into the inventory of the devices. So open up a standard inventory record, we'll see we have a state information section. That means that anything we're querying against, we can actually base that also on the device or the user state as well. So maybe we want to send information out to devices. In standard LANDesk, if we're targeting 1,000 machines across 50 sites, we're actually going to be targeting a fair percentage of those devices that actually aren't on. So we're waiting for LANDesk to work out if they are on, if they are installed, or if they're not, it's going to retry multiple times. If you want this to be truly accurate and fast, we can actually be targeting just against the systems that are online or in a particular state so that we don't impact users as well. So combine state information with inventory information to more accurately target and distribute and know the types of success rates we'd likely expect as well. So a couple of examples. All machines that are currently online, but these are logged off so they're not actually being used. All the online machines and the current states. So simple queries within LANDesk, but based on the actual state of the devices as well. So very powerful. Mentioned before as well about knowing when a system comes back. Maybe again on the XP client device, we're looking to support the user that's normally on that device. We could simply be chasing them all the time, calling them up, effectively chasing shadows when they're not there. What we can do is simply via right click of a single machine or a group of machines, we're able to access the alerting function of the tool. And simply to us as an individual, if we wanted to, or optionally we can actually put this message to any of the LANDesk groups within the system as well. Against XP client, I can set either a single alert that I'm interested in, or something that will always notify me of the change. Let me know when this system comes online. Maybe they've gone mobile, we don't know when they're back in the environment, so pop up a message to me when this machine comes online. In this case, because the user's logged off, I'm actually interested when they log back in to that system. So this client, tell me when it's logged on. So just save that. Dave's a very active user, so let's log him back in again. So that user comes back on a remote site, and meantime, as a support operator, we're still working away, but as soon as that information is notified back into the environment, here we go. Computer XP client, the user Dave Miller, that status changed from logged off to logged on, and now we can pick up the phone, we can send an email knowing that that user is back at their desk at that specific time. So if it's urgent, if we want to be responsive, they're going to think as if by magic we know that they're back in the office. So we could do that from an individual system perspective. We can also be doing that against groups of systems, and also perhaps we don't want the message popped up. Instead, perhaps we're interested in what happens to the device, but we want to be emailed about this. Perhaps there's an email group, we're monitoring a server or a critical device that provides an important function. Maybe the device that they're using for salaries. We want to know if that goes offline because that's important to us. So we add that in, and this time I'm interested in, let's just say, I'll do the user state again, but this time I'll just do it off locked state, so we've got something we can do fairly quickly. So that's been set now, but against an email, lock that device, and obviously from the console perspective we're able to see that that device has now gone into the lock state. We saw that before, but over on this person's PC we've now received the email from the system letting us know that that state has changed. So that could be to an individual or to a distribution group, perhaps even to the service desk itself, to make sure that a call is logged if that system disappears off the network, goes offline unexpectedly. Whether or not that device has a firewall or its IP address is changing, we're not reliant purely on the ping, and we're not purely reliant on the state being online. So again, user pop-up alerts, group alerts, and email individual and group alerts within the system as well for device and user state changes. So that's a quick overview of what State Notifier is giving to us, but we also have Wake-On-WAN within there. So simple thing with Wake-On-WAN is it sends a subnet directed broadcast, so it needs to know the MAC address and the target IP range, the target subnet that we're trying to wake on. Now in LANDesk terms, other than a targeted multicasting job, everything is sent either from the LANDesk core server or it is sent from the console where the operator is working, and that means that most Wake-On-LAN jobs are blocked by the router. Targeted multicasting works differently in that the representative that's elected on the remote site actually sends a Wake-On-LAN message within the subnet, so the router boundaries are overcome. But I don't know what you're like, I know many of the customers that we work with don't use multicasting for every job. Not everything's suitable. Certain things are ideal for install from source, for example, but if you want to wake a device, you're not able to use that. But also, targeted multicasting does have an issue in that it elects representatives either by using a list of representatives you selected, and if you've got lots of subnets, you don't necessarily have machines you can guarantee are on those subnets, or it will do a subnet directed broadcast itself to elect a machine, which sort of defeats the object since a Wake-On-WAN message is a subnet directory broadcasting gets blocked, or it uses one of the target devices. So for example, if you do a job to 10 machines with targeted multicasting on a subnet that contains 100 machines, your Wake-On-WAN representative can only be one of those 10 machines. The other 90 machines aren't even considered as a subnet representative. That's where Wake-On-WAN is different. So even enhancing targeted multicasting jobs, any device that is online on that remote subnet is potentially a representative for us. So we'll go beyond what targeted multicasting does and allow you to wake individual machines, wake groups of machines, simply wake a device. Maybe that's all you want to do in order to be able to support it, so ad hoc wake-ups. We can be scheduling that wake-up for any particular point in time, normal scheduled task, make it repeating, or we can be attaching it to pretty much any type of task you want as well. So wake the device, let it stabilize, and run this task, whether it's a targeted multicasting job or not. But notice, one thing we're not doing is assuming you want to shut the machine down afterwards, because you may not. It depends on what the job is that you're trying to do. Maybe you're only going to be waking some of the devices, others will already be online, so you can choose whether to shut down the machine or not. If you do though, lots more control over the shutdown than you would otherwise get with LANDesk. With a standard LANDesk shutdown, you're only going to have a few seconds to respond. You can't control the message that's presented to the user, and you can't really control many of the options. So as you can see from the options here, we have a lot more control. Maybe it's simply a standby or suspend. We can allow the user to cancel or not. Much more control over the countdown, and also customized message that we can provide to the end users. And critical, the integration with the state information for the devices. If half the machines were already on, were they left online for a reason? And if so, should we shut them down or not? LANDesk on its own doesn't know the device was online or even offline. Because State Notifier does, we know which ones we actually woke up. We know which ones actually came online. We're not reliant on pinging the devices, because their DNS record could have aged, their IP address could have changed. The device is telling it it's coming online because the State Notifier component is there as well. So we can only shut down the machines that we were responsible for waking as well, and avoid impacting the end users at all. So much greater reliability and coverage for the wake up, and much greater control over which devices we wake and which devices we shut down as well. Hopefully we see the benefits there. So coming out of there, let's have a look at just a few of the other configuration items we've got available to us. So some configuration options. Now, one of the things we have is, if your environment is one of those that is implementing 802.1x, that's a secure option. So if a device goes offline, rather than staying on the VLAN that it was a member of, it will be moved to a secure VLAN. In terms of vPro and in terms of standard Wake-On-LAN, that means that LANDesk doesn't know where that device has gone. It will be targeting the wake request to completely the wrong subnet. With Wake-On-WAN, even if you've done a partial implementation of that, we can be targeting the original subnet, but also we can be targeting the 802.1x subnet. So that we'll also be trying to wake it from within that environment as well. So again, powerful there. Obviously we want to be able to set the email settings, the accounts, the details, the potential addresses, and the email template, so we can have the right sort of structure for any alerts as to how it could actually be implemented within the service desk. And a few options within LANDesk. So a common problem that we do see is duplicate IP addresses within the LANDesk database. Now, LANDesk is good to tell you that a device has received a new IP address, but that doesn't cancel out the fact that another device previously had that IP address as well. So your users, or you may have encountered this when trying to remote control a device. You can see maybe from the console that the icons are showing that the device is online, but when you try to remote control it, you'll get a message that the wrong machine is responding. Very frustrating to the operators, and also an impression that LANDesk isn't working, when actually it's not necessarily LANDesk's fault in that case. Or software distribution, where it's contacted a machine, but because for whatever reason its IP address hasn't been updated, again getting wrong machine responded. So failure rates when you don't expect them to happen. Instead, with State Notifier, if you decide to enable the option, we will regularly check the database to make sure there are no duplicate IP addresses. If we find them, we will clear out the oldest record, we'll zero out that IP address record, so that the newest one, the one that sent its most up-to-date information, is the only one that will attempt to be contacted on that address. So clearing up and making more effective the data that LANDesk holds. And controlling the settings itself of State Notifier. From the idle perspective, what do we class as idle? Is it 5 minutes of use, 10 minutes of use, 20 minutes? We can actually set that within the console so that we can decide what we class as idle, whether that be for power saving or whether that be for knowing when the systems are simply not being used for update purposes. And if a device simply disappears, so if you've got laptop users, somebody simply disconnects the network cable, our agents obviously won't be able to tell us that that device has disappeared because there's no communication anymore. So we can also set how long we will wait, and there is a heartbeat from the agents to let us know that the system is still around, even if it doesn't have an update to let us know. If we haven't received that within 10 minutes by default, we will mark that system as offline, so to make sure that that information is completely current. So a few configuration options in the background there, so you can see it's not just the state information or Wake-On-WAN, there's a few other capabilities within there as well. So to recap on a few things, the technology for Wake-On-WAN is similar to the mechanism for targeted multicasting. We identify the target subnet of the machine that we're trying to wake, including as well the 802.1x support. We are choosing a representative from all of the potential machines on that targeted subnet. If you do have targeted multicast representatives already selected, we will use those as a preference. But we will also look at the most recently updated machines. If there are no preferred representatives, choose those first, the most likely to be on, but every possible machine there is a potential target for us to use. The first one we find we will use. And then we will use LANDesk in order to transfer and execute a separate Wake-On-LAN utility. So we are not reliant on the LANDesk Wake-On-LAN method because, from experience, it has the occasional time where it's a little bit flaky. It's not necessarily the number one priority for the developers for testing when patches come out. And ultimately, again to recap what we're getting, much greater visibility of the environment, accuracy, utilization, availability to use in whatever manner best suits you. Knowledge about those states to be able to monitor them and to alert on those states as well. And to make sure that this is more than useful just for, it's not just for the third level operators, the second level, the first level can use this to increase their responsiveness to the end users. And you as an organization, an IT organization, could provide a much better service, a much lower impact service through out of hours maintenance if you're not already doing it today, or if you are, improving the effectiveness and the control of that as well. We'll go on to the questions shortly, but just so you know, there is a full trial of this software available. So the State Notifier Wake-On-WAN is very simple installation. They are both together in the same installation. There are no services involved in this at all. It is a very simple install. If you do need some assistance, simply to run through, answer a few questions, do a bit of over the shoulder, we regularly do remote assistance, and that is free of charge for anybody evaluating and also implementing as well. We'll just do that remotely for you. If you're interested in the licensing type, it is licensed by LANDesk managed devices. So for each of the devices you would require a license, but it is priced very cost effectively. State Notifier and Wake-On-WAN are bundled together. So this is something we're doing towards the end of this year, and that's £3 per device, and that gives you both State Notifier and Wake-On-WAN. If you're an existing Wake-On-WAN customer, then you are eligible for a discount to upgrade to the combined product. And if you're education or a non-profit organization, you could be eligible for a 50% discount within there as well. For those of you that really just need Wake-On-WAN, there are plenty of you out there, you can still license that separately if you wish, but we do feel that together they make a very effective combination, which is why we've given that option and the installation together. Okay, so remember there is the question section in the toolbar. So if you do have a question and you haven't put it in there, take the opportunity to do it now. So what we'll do is we'll go through the questions that we have received so far. First one we received is about the installation. How hard is it to install? It's a single MSI file that you would install on the LANDesk core server. It literally takes seconds to install. So anybody that actually has evaluated it will know how quick it is to install. It does have a separate database requirement, to be perfectly honest. We do that because we don't want to impact the LANDesk data in any way except for key things used for inventory. That can be created automatically during the installation if you provide us credentials that have the rights, or your DBA can put it as well, but it is a small database within there. And again, that's very quick install. Small console plugin, which you can single file MSI, which you can distribute to the people you want to have it, and a small MSI agent that you would add within your LANDesk agent so that we have something to be monitoring those state changes and to send the information. We do have a question: how does State Notifier impact network traffic and database size? So the database size is very small. We're talking just a couple of pieces of information about the device when the state changes. So nothing like the sort of size you're going to expect for the LANDesk database. It won't affect the LANDesk database size at all because we do keep it separate. So that, again, we're not going to impact the performance. Many organizations are running this on SQL Server Express, so no issues there. Network traffic, if we're going to be updating real time, there will be a small amount of state data going across the line. That is a small compressed text file, and that contains simply the ID of the device, so the LANDesk device ID, the identifier for the state, so whether it be a user state or a device state, and the state that it has moved to. So you're talking effectively 3 pieces of information plus a username if that's what's changed. So you're talking bytes worth of information going across the line when that gets sent. There is a question as well, will this work through the LANDesk gateway? This doesn't work through the LANDesk gateway this time. LANDesk don't unfortunately expose that capability. To us, when we're looking at devices that are mobile, we're not considering those as online, simply because a lot of the reason for this information is to allow you to support a user that is available now and to effectively make changes to that system when they're available. And the gateway at this time as well doesn't allow you to do push distributions. It's all policy based anyway. So no, we don't go to the gateway, but that is by design, so you can see systems that are online within your environment and users. Another question as well, targeted multicasting Wake-On-WAN. We've been using this and we have had some success, but how does this work differently to that? Now, I did cover that earlier on, but just to recap, the targeted multicasting method for Wake-On-WAN is only applicable to a targeted multicasting job, which, as you probably read, doesn't necessarily suit all types of distributions. And, as mentioned, it is limited in the representatives that it will potentially select. Now, it will only select from the target list unless you have already assigned preferred representatives. So, because we're allowing this to be through unicast distributions, ad hoc distributions, and also we are using potentially any of the machines that are available on that subnet, it's much wider, the capabilities, what you can do with it, and much more reliable in the way in which it's able to get that message sent. Final question for the moment, unless somebody else adds in there, is there an annual charge? Okay. Oh, and we got another one in. What's the cost per device for the US? So I'll just go quickly on the cost for the US. Obviously we've put UK prices there. It's slightly dependent based off the actual exchange rate at the time. So that's something we'll make sure that we're able to provide across to those people that are interested, so you can see that at the particular point in time. But you can see there that there's no price differentiation between the UK and the US. We're simply just going to do the conversion. There's a question, is there an annual charge? The price you see there is the full price for the first year. That includes maintenance. So if we looked at State Notifier and Wake-On-WAN, for example, that £3 is a perpetual license for the software plus annual maintenance. So there is an annual update there simply for new product support, new product versions and updates, and product support, that it split the £3 out to be £2.40 and 60 pence. So you can work out the approximate percentages there, about 20%-ish as an annual maintenance charge. It is not the £3 or the £1.50 per year. So simply the usual annual maintenance that you would expect for supporting the products. Okay, well, hopefully that's been useful for you, giving you a good idea of what the product's capable of, what it could potentially offer to your environment, and how cost effective that would be to your environment as well. If you do have any other questions, please send them through to the address here. Well, I believe a lot of you have been contacted by Stuart, so if you've got Stuart's contact details as well, by all means fire them across there, and we hope to work with you in the future. Thank you very much for your time.